In lesson 20, we're going to learn about piecewise functions and what they are, so that we can later apply transformations to it. What are piecewise functions? Piecewise functions, you can always Google anything that you don't understand that is said in these videos. So I'm going to Google what is a piecewise function. And there I have the definition. You also have videos that you can look at. So if this video is not enough for you, please by no means stay to it. Find your own way that works. So piecewise functions are functions that have multiple parts, or multiple segments, or intervals, however you want to call it. Each segment has a specific domain. And on that domain, they will be considered continuous, meaning that they have points that are not whole numbers, right? So every fraction of a point counts. So as we learn about piecewise functions, we are going to go back to this definition of these three things and make sure that it fits in there. Piecewise functions are super useful. We can use them in the financial area, for example. So if we wanted to talk about the different types of payments for mortgages or any kind of loan situation, sometimes for a specific interval, so from year 1 to 5, you're going to have one interest rate, and from year 5 to 10, you might have a different interest rate, right? So those piecewise functions come in very useful for that. And then also any kind of scientific problem, grades in a class, for example. There are multiple times where one equation is not going to be good for the entire function. It might be just good for this one interval, and so that's when piecewise functions come in. We have an example of a piecewise function here with 3 different intervals. So when x is less than or equal to -2, then we have an equation that goes for that, and that equation is -3x minus 3. I'm going to use Desmos to graph this so that we can see it. In Desmos, you have to specify the domain first, use a colon, and then put the equation there. And then separate each interval with a comma. I'm going to do it for you. You don't need to do it on your own. And actually, in class, you won't need to know how to do this with your graphing calculator either. The second interval in our function is when x is less than 2, but greater than -2. You can see that that slope is different than the first one because it's a completely different equation. And that's how we start putting together the graph of this piecewise function. The next interval is for all those x's that are greater than or equal to 2. So the domain for that is 2 to infinity. And that has the equation of -2x plus 9. As you can see, the graph is put together, and that's what the graph would look like. Because this is a function, your x values are not going to repeat, so you're never going to have a situation where x equals 2 is something different. So your values are going to be either x is less than 2, and then on the other interval, it might be equal to 2. So just try to keep that in mind. And going back to our original definition of what a piecewise function is, it does have multiple parts. We can see here the multiple segments, the different intervals. Each segment has a specific domain where they don't repeat an x. That's what makes it a function. And on that specific interval, they are continuous. So if I were to go in between these, I could see that they have fractions of points that are values for x. So the task here is, are you going to be able to look at a graph and write a piecewise formula for it so that eventually you can come up with the entire piecewise function? Let's go ahead and try and do that. Here's a graph, and I'm going to do this on my own. You can always pause the video and try to do it on your own as well. It's not hard. You already know how to write equations for a line, so you already know how to do that. All you have to do is just specify the domain, and that's the only way that these are different. So go ahead and give it a try while I do mine here on the side. I went ahead and specified the 4 different intervals for this function. And then I'm going to start writing my formula. When you start writing my formula, I'm going to use either mx plus b as the equation to plug in. But the problem here is that I don't know what y, x, b are, and some of these intervals don't have a y-intercept, so it might be a little hard for me to do that. I might need to use the point slope formula for this equation, and I kind of forgot what the point slope formula was, so I'm going to use Google, my friend Google here, and Google what that formula is. Point slope formula. Oh, there it is. Just gonna go ahead and copy and paste it on my notes. There I have it, and I just start plugging it in. I grab 2 points from that first interval that I can use to find my slope, and then I can also use one of those points in my point slope formula. My slope is rise over run. I don't need to look up that formula. And I can just subtract -3, -2, get a -1, divided by -2, do the math, your slope is going to be 0.5. And then you just plug it into the point slope formula with a point. I'm going to use point -3 and -2 for this. All right, so I have my formula there. I always want to go back and plug it into Desmos just to make sure that I'm doing this correctly. And then I also want to make sure I write, before I do Desmos, my domain in the appropriate way. So I look back at my notes just to see how they want, what notation they want this domain written as, and then I just plug it in. That graph looks pretty good to me. It looks pretty similar. There we have the -4. So now I'm going to move on to my second interval and see if I can write an equation for that. This would be a great time for you to pause the video and try this on your own if you didn't for the first interval. In the next video, I'll give you the answers.